Hello Year 7. Your first job, I want you to take 5 minutes, maximum 5 minutes, and I want you to just sketch out, just a real rough drawing, a little sketch in rough, of what you think a scientist looks like. So just have that little sketch, just a sketch, doesn't have to be the most detailed and amazing drawing, but just a little sketch of what you think a scientist looks like. Okay? I want you to pause your video for those 5 minutes until you finish your sketch, so pause it here. Okay, so if you haven't finished those 5 minutes and drawn the diagram, you've got to stop the video and finish that before we go on to the next bit. Okay, but if you have, excellent. Okay, now I want you to look at how many similarities your drawing has with these three. Does your drawing have a man in a white coat? Okay, does your drawing have a white coat in it? Does your drawing have a man? Does your drawing have the scientist wearing glasses? Are they holding some kind of beaker with some kind of liquid in it? Are they looking in a microscope? Do they have a mustache? Do they have crazy hair? Okay, how many similarities does your drawing have with these? Okay. Now, we all have biases when we think about what a scientist is, I think. This is what I think of when I think about a scientist. We've got James West. He developed a microphone that I'm using to record my voice. He developed the microphone that's in your phones. Okay, he's done lots of research into stethoscopes, into medical listening devices. Okay, Marie Curie, one of my personal heroes. Okay, the only scientist in history to get awarded a Nobel Prize in Physics and a Nobel Prize in Chemistry. Incredible woman. Okay, Jim, I can never say a second name. Okay, two theoretical physicists, amazing communicators of science. Okay, Jim and Brian Cox. Okay, we've got amazing Grace Hooper. Fundamental work in computer science. She was the first person, she coined the term a programming bug. Okay, worked on some of the first computers in the US military. Okay, really important for how our computers work today. Neil deGrasse Tyson, amazing science communicator. Okay, he's got a fantastic book on cosmology. He's got Rosalind Franklin, did pioneering work on X-ray crystallography. So she allowed us to see DNA. Roy Sanders, he's my old boss. Okay, he got me through my PhD. Okay, so these are the people I think of when I think about what a scientist is. Okay, now we've got some pretty ugly things happening in the world at the moment. Some pretty ugly things happening in the world. And the point of this little exercise, I just wanted to get you to think about that a scientist doesn't look like anything. Okay, because a scientist comes in all shapes and sizes. Okay, all races and genders. If you want to see what a scientist actually could look like, just grab yourself a mirror. Now, this week, we're looking at what is a scientific method and how to write one. Okay, so a scientific method is really similar to a recipe. Okay, it's really similar to a recipe. Okay, it's a list of detailed instructions needed to carry out an experiment. But it's got to be more detailed, it's got to be more precise than a recipe. Okay, because as a rule, scientists, we're not very trusting. We don't just take it on faith that an experiment will work. We don't believe your results. We want to be able to check. We want to be able to check everybody else's experiments, do what they do. Okay? Because if I can't repeat your experiment and get the same results, then it's not valid anymore. I need to be able to repeat your experiment and get the same results to make sure that it's true. And to be able to do that effectively, I need to be able to read your method, to read that set of instructions, to replicate it. Okay, so it's got to be really, really clear. It's got to be really, really detailed. Okay, and as an example, I'm going to follow this method from Yorkshire Tea on how to make a cup of tea. Okay, so that's the next part of the video.
Okay, boys and girls, so I've got Yorkshire Tea's website up and it's got their method for how to make a cup of tea. Now, a good friend of mine sometimes watches my little videos on YouTube and it's his favourite brew. So it's one of the reasons why I picked it, but it's also one of the few companies that have put out a method. And I'm going to try and follow it to the best of my ability. Okay, now the first, it doesn't have an equipment list, so I'm making some assumptions. I've got a kettle, because there is a diagram of a kettle. But I've got a mug and I've got a tea bag with some tea in it. Now the first instruction says treat your water kindly. That's good water. Run the tap a little so it's nicely aerated. Only boil it once to keep the oxygen level up. Wow. Oxygen in water helps flavour. I'm not sure how helpful that instruction that is. But looking at the picture, it's got H2O written at the side of it and it's got a cloud. So I'm guessing the water has to go in the kettle. The water has to go in the kettle and I turn the kettle on. I'm assuming that just from the picture. Now, it doesn't say that in the instructions, but it's got it in the picture, so I'm going to do that. Right, what comes next? Next, according to Yorkshire Tea, is add tea and water. Pop a tea bag in your mug. So pop a tea bag. It's a bit weird. But it says pop a tea bag in your mug and pour over the hot water and stir briefly. So, tea bag. It says pop a tea bag in your mug. That's what it says. Pop a tea bag in your mug. So I guess let's get rid of that. There's the tea bag. Pop a tea bag in your mug. So I've done that. There's the tea bag in the mug. There's the tea. And pour over the hot water and stir briefly. So I pour over the... So there it goes in. No, that's a stupid thing to do. Let me use a stirring fork. Stir briefly. Done. Next. What's next? Wait patiently. Tea needs time to unlock all its flavours, so give it 4 or 5 minutes to do this thing. There's the perfect time to maybe clean up this tea that's on my laptop. Perfect time to have a biscuit. It says to munch a sneaky biscuit or daydream about the holidays. Oh, we just had the holidays. We could do a little daydream about them. That'd be good. All right, let me just speed the video up. And 4 minutes later, what's next? Give it a squeeze. Before removing the tea... Oh, I need to use the fork, I guess, to remove it. By removing the tea bag, because look, there's a picture of... I can't see what it is, but it's got like that shape on it, so I'm assuming it's a fork. Before removing the tea bag, gently squidge it against the side of the mug. Just once, mind. If you really smash it, it will taste bitter. Okay, so let's get the tea bag. I must take it out of here. And it says to put it against the... Oh, that's quite hot. Remove the tea bag, squeeze it against the side. So I've got the tea bag in the mug again. And let's squeeze it on the side of the mug. Just once, and then we take it out. Right, what's next? Customize your brew. We like to add a splash of semi-skimmed milk. Yeah, I like some semi-skimmed milk. That's a good idea. Some milk. Just a splash. I guess that's a splash, maybe. Kind of splashed it at the mug. But your brews, there's more instructions, but you could add milk, sugar, honey, lemon, or nothing at all. So we could have had it on its own. And most importantly, enjoy. So there's my tea, supposedly. It's not very good. But I followed the instructions. I followed the method.
all seemed to go wrong in this step, did it not? Bit silly of me to tear the tea bag in half and pour the tea onto the table. Okay, but I followed it. Pop the tea bag into your mug. So I'll just put that tea bag into the mug. How could you write this instruction to make it clearer, to make it less open to interpretation? How could you change it? Okay, because in everyday life, this would be good enough. People have some common sense, and we could use that to figure out that, oh, actually, I don't need to tear the tea bag in half. I just put the whole thing into that mug. But when we're writing scientific methods, okay, we've got to make we've got to be clearer. We've got to leave it less open to interpretation. Okay, and here's an example of how we could maybe do that. Which of these two instructions in a scientific method is better, and why? So the first example is put some water in a beaker. And 2, using a measuring cylinder, pour 100 millilitres of water into a 250 millilitre beaker. Which of these two is a better instruction? I think it's 2. I think it's 2 because it uses measurements. It tells me what I'm using to do those measurements. It's got more detail. Okay, I know that I need to put exactly 100 millilitres of water into that 250 millilitre beaker. This instruction, I've no idea how much water I could put in. I could put in 10 millilitres, 1 millilitre, 100 millilitres, a litre. I don't know. Some isn't detailed enough, it's not accurate enough, it's not precise enough. Okay, so 2 would be a much better instruction. Now your task this week, you need to write a method for making a cup of tea. You need to write a method for making a cup of tea. You need to have clear step-by-step instructions. Okay, I would lay it out like this in green, where I've got 1, 2, 3, 4, 5, 6, however many numbers you need. I would do it in order of number like that. They should be clear and detailed. Include measurements. How much water? What temperatures does the water go to? Okay, have at least one labelled diagram. A diagram is different from a picture because it's labelled. You don't need to be an artist to draw a diagram because you're labelling it. You're telling the reader what everything is. Okay, you've got to include an equipment list. What equipment are you using to make that cup of tea? Okay, that is your task for the week. I hope you have a fantastic time this week. Take care of yourselves, take care of your family, and maybe if you make a really good method for making a mug of tea, maybe you should use that method and make it for somebody in your home. Take care. Bye-bye.